I'd like to talk about the lithosphere. The lithosphere is a solid and rigid outer layer of our planet. It includes the crust in the upper part of the mantle that contains rigid rocks. You will notice in this picture that the lithosphere is the top layer of the Earth. Because the Earth consists of land and water, the lithosphere can be subdivided into oceanic lithosphere and continental lithosphere.
First thing we need to know is this. The outer shell of the Earth, which I gave an example of being the magic shell on a scoop of ice cream, the solid outer crust of the Earth, we call it the lithosphere. It's actually broken into pieces that we call plates. You see them here. You can call them lithospheric plates, you can call them tectonic plates, or simply plates. But this is the solid outer part of the Earth that we live on. Some of the plates are all oceanic crust, some of them are all continental, and some are a combination of the two.
The lithosphere, or the crust, is not just made of one big piece, but it's actually made of plates. So we're going to draw two plates from the side, like this, all right? So we've got two plates, and the Earth is actually made up of 7 or 8 plates, depending on how they're counted. And there's two kinds, all right? So the first kind is oceanic. Oceanic plates it's easy to remember because they're under the ocean. They're usually covered with water. They are relatively thin and dark. It's actually a very dark black rock, generally made of a rock called basalt. All right, so thin, heavy, dark rock. Then there are continental plates, which are usually above the ocean, usually made of a thicker plate, much lighter. We'll speckle it because oftentimes it's made of granite. And you might be thinking, wait a second, Ray, granite is actually pretty heavy though. But it's not as heavy as basalt. Basalt is quite a bit more dense or heavier, so when they interact, usually the basalt sinks beneath the granite. All right, so those are the two different kinds of plates. And then the interesting thing about tectonics is that they move. Plates move because of two main things, and the first most important thing is something called convection, or convection currents. If you've ever seen a pot of water that's boiling, right, it's on your stove, and there's heat coming up from the bottom. It causes water, the hot water in the center of the burner, to rise, and then as it goes around the side of the pot, it cools, and you can see there's a little current formed there. There's another one on this side. That's called a convection current. It's these currents that form when liquid is heated. Well, the mantle is liquid, and the core is extremely hot, and it causes mantle to rise and fall in much the same manner. And it causes these currents, these circular currents that start at the center of the Earth and then sink back into the core. Now you can imagine that the plates, these solid plates, are floating on the mantle, and the mantle is moving in this way, and just like a ship on water, the plates are going to float off to the right or to the left as a result of this kind of flow.
Okay, so we have covered the types of movement and what causes our plate tectonics through convection and convection currents. And this is happening so slowly that we can't feel it. Remember, it's happening about as fast as your fingernail is growing. So then we have our lithosphere and the types of crust that it is composed of. So the lithosphere, also known as tectonic plates, is made up of oceanic crust, continental crust, and sometimes both. So in our picture here, all of these red lines show us boundaries. So the boundary is where the two different plates meet. So here where you see the oceans, so all of the area that is water, our ocean, the blue, that is made up of oceanic crust. Oceanic crust is a very dense material, basalt, and it makes up the ocean floor. Then if you look here in all of the brown areas, these are our continents. And our continents are made up of continental crust. Okay? And continental crust is less dense. So we have continental crust where our continents are, and oceanic crust where our ocean floor is. If you notice, we have some plates that are all one type of material. But if you look here where my pointer is, we have oceanic crust and continental crust. So some plates can be made up of both. So now we're going to look at our types of boundaries. There are 3 different types. Remember, a boundary is where 2 tectonic plates meet. So the first type that we are going to talk about is a divergent boundary. And this occurs when 2 plates move away from each other. And in a divergent boundary, the magma pushes up through the asthenosphere and is creating these new layers, this new crust. Okay? And the formation of this new crust, these layers, can be found along a mid-ocean ridge, as you can see here, just like we talked about. So when 2 plates come together or start colliding, pushing against each other, we have a convergent boundary occurring. Convergent, you can think of collide, come together. And in a convergent boundary, we have a denser crust. And that denser crust starts sinking below the less dense crust. And that is called a subduction zone. Okay, so where it starts to sink, it subducts. And if you can remember in class when we talked about subduction zones, that is where the one plate sinks or subducts below the other. And in our subduction zone, the crust is recycled or destroyed as it melts back into magma in the asthenosphere. And our last boundary we want to talk about is a transform boundary. If you look at the visual here, the video, you can see that the plates are sliding against each other. So this occurs when 2 plates slide against each other. And sometimes during this sliding, they can stick and they become stuck, building up this energy. And then once the energy is released, we feel earthquakes.